Welcome to Stemiverse podcast episode 21. In this episode, Peter and Marcus talk with Lael Grant. Lael is a computer programming teacher at Barker College based in the Sydney suburb of Hornsby in Australia. At the college, Lael is the team coordinator and part of the mentor team of the Barker Redbacks. The Redbacks have established themselves as one of the leading robotics teams in Australia. When Lael is not planning the future of robotics and STEM education at Barker, he teaches programming as a part of the computer science faculty. We interviewed Lael and two student members of the Redback team at the Barker College campus. The result is a two-part episode in which we discuss the importance of using robotics as a vehicle to develop multiple skill sets and attitudes in students. In this first episode, Lael talks about robotics education in Barker College and the benefits of cooperative competition. In the second episode, two student members of the Redbacks team, one current and one alumni, give us a student perspective of what team membership is like for them and how it has helped them develop technical, personal and interpersonal skills. Saskia, a current member and one of the team captains, is in year 11. And Alistair is a team alumni and now studying engineering. I'll take one more minute in this introduction to give you some background on the Redbacks robotics team. The team grew from a small number of students in 2014 through to their successes in 2017. In 2017, the team competed in Australia and around the globe in the first robotics competition, FRC, the first tech challenge, FTC, and the VEX robotics competition, VRC. The team won the most regionals of any team in FRC and were finalists in their division at championships. This is Stemiverse podcast episode 21. Welcome to Stemiverse, the podcast that helps educators become awesome at teaching STEM, be it at home or in the classroom. I am Peter Dalmaris, and with my co-host Marcus Schappi, our mission is to bring you the experiences of educators, students and stakeholders who strive every day to make the teaching and learning of science, technology, engineering, mathematics and art better. So Lael, thank you very much for inviting us to Barker College, an amazing campus here in Hornsby. A nice sunny day as well. We didn't get lost this time. So we are here. Actually, tell us, where are we? What is this place that we're sitting in now?
Absolutely. So we're currently sitting in the robotics laboratory. We're upstairs in the office, but the robot lab is basically underground in an old drama theatre room. And that we got to take over when they moved into a new building. So that's our space. Yeah,
so we spent a bit of time looking at it earlier, and you've got a setup with a couple of Lego robots in a, I suppose, how would you call it? Not a container, but like kind of pitch.
Like a field, yeah.
A field.
Yeah, so basically at the moment, what you would have seen is the two fields one for VEX Robotics and one for FTC. And VEX is basically almost like a Meccano-like robot kit that you'll put together, and you've got all the components there ready to build a robot. FTC is very similar. Most people use like a Tetrix, is what they call a Tetrix kit, which is very much the same thing. Slightly different bent and focus between the two competitions. And then, you can make custom robots. And so for us, for FTC, we make completely custom robots.
We'll come back to that later. Yeah. So let's rewind and go back to the beginning. And I'd like to ask you to tell us a few things about yourself, maybe about your background. And we want to see why you are interested in robotics, and then what is your role in robotics or STEM education here at Barker College?
Absolutely. So I'm the coordinator of robotics at Barker. So basically I'm responsible for the strategy and planning across the whole school for how we integrate some of our STEM ideas in practice. And so for us in robotics, it's basically we're going from junior school where we do Lego and we build Lego there all the way through middle school, and then senior school where we do FRC. So the middle school...
Sorry, what's FRC?
Oh, sorry, yeah, all these acronyms, right? Yeah, there's going to be a lot of them. FRC is called the First Robotics Competition.
Yep.
And so that's you build larger robots. The robots are about 1 meter wide by about 1 meter long, and then anything up to 1.5 meters tall.
Big fellas.
Absolutely.
Is that an Australian competition or international?
So it started in the USA. So it started out of New Hampshire in the USA, and a guy called Dean Kamen, who invented the Segway, sort of said, we want to inspire people to be involved in STEM.
So what's a Segway?
The Segway, yeah, indeed. And so they then said the best way we can do that is by making something that's really attractive to students. It's like a competition.
Yeah.
How do we do that? Well, I don't know. Let's put a robot competition together. So they have to implement STEM skills across the spectrum, all in one sort of package. And that's where it all came. That's where it all started. So Vex and First actually started together, and then after a number of years, the competition sort of split into 2 separate competitions.
Yeah. So how come you're doing an American competition?
Because there are no Australian robotics competitions. Yep.
Really?
Yep. Nothing that I'm aware of that's actually started here in Australia, and nothing that's as large or as competitive. So in FRC, for example, in the first robotics competition, we're competing against, there's a number of universities in Australia which are sponsoring teams. So the students are all high school students, but then the universities are actually providing the mentors, the engineering students and things like that. And then we're also competing against teams in the USA that are mentored by large corporations like Qualcomm, NASA, that sort of thing. So the playing field is a little bit more rigorous and challenging. And that's really nice to really extend where your students can go.
Are you just getting thrashed? Or?
We're doing pretty well. We're doing pretty well.
We are sitting right next to the trophies.
I jest. This room is really a trophy room.
Yeah, it's
a recording studio.
Yeah, we've actually got, I don't know, this year we had a very successful year. So we were fortunate enough that we were invited to compete in China, in Shenzhen. So this is the very first regional that the FRC had ever seen in China. And we've been sort of working with an organization in China to bring robotics and the FRC competition to China for the last 3 years. And during that time, each year we go over and help teach a few teams how to build robots. And then we have a competition with the international teams that have gone, plus all the Chinese teams. And so often in that competition, it's some of the best teams, international teams in the world, and then a bunch of rookie Chinese teams. So it's always a fun competition to help them, see what a competition is like and see them get sort of improve really, really quickly.
How do you teach the Chinese how to manufacture and make robots? You would have thought that it's the other way around.
Yeah, a lot of people say that. There's a few things culturally in China which are very different to the way people learn in Australia. And one of them is because China has a much more stratified society. There's much more of a hierarchy in how you treat and defer to elders and teachers and things like that. And so one of the challenges we have is helping the Chinese mentors to allow the students to express their ideas and to make their choices. And so this year, one of the struggles we had was students that would say, oh no, we can't change that. Our teacher did that. Right? And so because our teacher did that, that must have been right. Yes. And so you sort of have to encourage a bit more dynamic play in relationships, and that's always a little bit delicate. And in our team, there's always rigorous discussion around designing and everything else like that. So totally different feel in some ways. And so part of it is sort of trying to help change a culture of designing and thinking and innovating. Yeah, so that's part of it. And then the other part of it is helping, a lot of these kids are students of, to be frank, well-to-do Chinese families, right? And so they haven't necessarily been in a culture where they've developed and made their own things. And so teaching them some basic skills and then teaching them how to put some concepts together. But their growth over 3 years has been enormous. So we've got teams that 3 years ago couldn't really put the robot together by themselves and are now making very sophisticated mechanisms. So they will become very challenging very quickly.
How do the students communicate?
With difficulty.
In binary language.
Yeah, so we try, if we can. We've got a number of students at Barker who are bilingual. They've grown up in with families that are Chinese in Australia, and so sometimes they're able to come with us. And then they also normally, the teams that are involved in these workshops have English speakers within them. So they normally try to encourage the teams to make sure they have at least 2 people that can speak English quite well, and their capacity to speak English is phenomenal. So we were in a place called Zhengzhou, which is a small city of a few million in China. That's right. And we and the middle school, there was a middle school there where they were at, And I think there was thousands of students, and all the students that we interacted with, I mean, they may have very well selected them, but every single one that I spoke to there spoke very, very fluently, which was, it makes it very easy.
There's no barrier there. It's probably the cultural differences are more important than the language differences.
Yeah.
I wanted to ask you about the FSC. Again, take a few steps back.
Sure.
I've seen the videos, and it's very exciting. It reminds me of like NBA finals game. It's a very exciting atmosphere.
A lot of suspense.
It's amazing. The speakers over the loudspeakers preparing the crowd for the next big match. So I can see why it's very, very exciting.
Right.
But from a learning point of view, a learning perspective, what do students actually get out of in getting involved, not just in robotics, but competitive robotics?
Yeah, sure. So if students are involved in robotics without the competition side, there's less motivation to produce something that's really excellent, because you don't get the same feedback. And that competition side, it sounds small, and yet it's everything. It really is. And so for our students, there's a few things they get out of it. Number one, we have students come along because their friends are here, and they see their friends are doing something, and their friends talk about it, and they obsess about it, because you've got a six-week build period to build the robot, and that's all they do in their summer holidays, right? So from, that instead of spending their day at the beach or whatever, they're coming in. Sorry?
They come to the lab instead of Bondi Beach.
Yeah, it's ridiculous and fantastic all at the same time.
I can see myself there.
That's right. Yeah, so in the middle of summer, we'll have students in here from about January 7, and they're here full-time for about 2 or 3 weeks building this robot, and then school goes back, and they've already been at school full-time for 3 weeks. It's amazing.
Crazy.
It is.
We can do that as little kids.
Yeah.
So the competitive drive to build something better than the other team,
right.
The thing is what differentiates just being interested in robots as opposed to being interested and creating something amazing that's better than anybody else's. So you believe that learning process there gives your students the edge.
Right. It drives a whole lot of motivation.
Technically as well as perhaps from a personal point of view.
So for those students who come in and they're just interested because their friends have come in, they see the excitement, they see the draw card, and they become interested. It's usually when they go to a competition that they suddenly say, this is incredible, I want to be involved. And so normally after they'll join us for one season, and they'll sort of be on the periphery, and then after one season they're hooked and they want more. And so we see students come in who, their grades are good, but then suddenly they see a reason for maths, they see reasons for science, they see a reason. Right. And so when you're talking about, how does it drive learning, how does it drive that technical understanding, it drives it in a really fundamentally deep way, right? Because you've got students who, they come in and they see this game, let's say last year, where you have to shoot these 10-inch balls, grey foam balls, into a tower that's, 2.5 meters off the air, and you've got a reflective strip around the outside of the goal. How do we get it in there? And so suddenly we've got students who are saying, hey, we could use vision tracking, right? We could shine a light at the reflective strip, and if we write the right algorithm and use some vision processing, then, hey, we could be scoring much more accurately than we currently are. And so the same student who may engage with learning in a classroom where you're teaching some concepts and you're teaching the same thing to every student, right? So you're trying to hit particular targets for everybody. And that's fantastic. And you get to a point where the entire class hopefully has come to some sort of level of competency. But while you give open-ended projects to them, it doesn't inspire the imagination quite the same way as saying, if I can shoot more balls into this goal, and then I'm going to compete in Sydney against other teams, and if I win that, then I'm going to go to the USA and compete.
Imagine the glory there.
Yeah, and I can play against teams from NASA. I can play against, these teams like 254, the Cheesy Poofs, who've won so many regionals, right? Or, like 1114, the Symbotics. Like, there's so many dynamics at play for the students where the motivation just ramps up enormously. And the capacity for them to make decisions about what they choose to pursue in depth is really open. So they can choose programming, they can choose, I want to understand the mechanics of how to build a gearbox.
Because there's a team around the project, right? So people can not just specialize because somebody tells them,
right?
But they probably find an affinity towards the mechanical part of the robot, right? Or the
programming side,
maybe even the business.
Exactly. Yeah. And we've even got students who are now saying, we're doing the robot pretty well now, but what about our branding? How do we bring that about? How do we communicate more about who Barker is, more about who the Barker Redbacks are, and our vision to help other people get involved, right? About our vision to actually make robotics something that's not just for some people, but for every student in Australia, right? And so there's a real motivation and drive there. So one of our students, after championships, he came back and he said, oh, so we had this, we had the holiday and I didn't have much to do, so I built a new website. Do you want to take a look at that? And it's like, yeah, of course I do. Let's have a look.
What's wrong with your mind, right? It's good with friends.
They do. They've got great friends, but they just love it. They just love it. And it's, it's part of, I think they see the value they're getting from the program as well, right? And so it means that they're involved in it for so many hours that a lot of them, their best friendships do become a part of robotics. And what a great thing, right? To be involved with a bunch of students who have a vision for high technical capacity. They're going to be, one of our students just won the New South Wales Young Scientist Award. He's going on to the BHP Awards, potentially to the Intel International Science Fair Awards, where that's the sort of student that we're trying to produce.
Yeah, I want to talk to you more about what happens after these competitions, right?
Where do they go from there?
Let's go before that.
Yeah,
sure, yeah.
Actually drive there. So just as you were talking, I was just thinking of competitive sports, like I was talking about basketball, NBA Association earlier, how it's a team sport, and robotics, intellectual activities like that tend to be looked at as solo activities.
Right.
So you just sit at your desk with a book.
Right.
But it seems like there is an extremely team sport.
Absolutely. And even more than the team, right? It's about the whole community. And so one of the things that you sort of see very quickly in robotics is that there's a great depth of technical understanding you need to actually get started. And so for a lot of teams who say, hey, we want to get involved in VEX, we want to get involved in FRC, the first question is, how do we do that? That's really challenging. I'm not sure if we can make that happen. And the answer is that there's a bunch of teams that are involved in the competition who want to help, right? Like Barker College and Barker Redbacks. Like the main aim, one of our main aims is to make sure that every team that can or wants to can get started. And so, for example, in the last few years, we sort of helped a team from Ravenswood get up and going, from Abbottsley, from Pymble Ladies College. Like every time we can, we'll help somebody. So if anybody who's listening and says, hey, like please contact us and we'll help
we'll
as
have
much
your
as we
contact
can.
details later.
Yeah, fantastic. And so our students, they make connections not just with themselves, but then with all the other schools they compete with. And in all the competitions that we compete in, you're competing not just your own team against other teams, but you're competing your team with other teams against other alliances or other teams. And so that means that there's this intrinsic sort of incorporated motivation, not just for your robot to be the best, but to help your other teams be the best as well. And so you're trying to build the overall capacity of the entire competition to achieve more greatly, right? And so for us, we're trying to push the boundaries technically of what our team's capable of, because our aim, we would like to be one of the top 10 teams in the world, right? That's our stated aim, is we're trying to get there. That's going to be really tough. And we don't know if we'll ever get there. We don't know, because everybody else is aiming for the same thing. But as we do that, there's a whole bunch of cost in that, in developing, new innovative ideas, in training programs, in getting our students to design and come up with new ideas. And as often as we can, we sort of help other people with those as well. So we're sort of trying to pioneer, and takes more effort and time and resources, and then hopefully we can make it a bunch easier for everybody else who's sort of coming along and making that happen. And that's the aim.
So the collective capability in building robots within the competition continuously rises.
Absolutely,
right?
yeah.
So everybody gets better all the time.
Exactly. So for example, 254, who's a team who's mentored by NASA over in California, they just released their technical binder for the year. And their technical binder tells you everything about their robot and everything that they produced, how they did it. That is, that they produced a blog for the year, so you can look through and see how they're designing their robot through the process.
They're competitors, so they're one of the competitors. They documented everything that they've done.
Is that last year's robot, or
so they will. Everything gets released after the season.
Okay.
Yeah. So
there's
it's not
a bit of a competitive.
Of course, there's absolutely the amount of effort and time that goes into it. There's always going to be a competitive edge that everybody's looking to leverage. But everybody's also looking to help everybody else be better at it, right? And so
it makes so much sense. Like, if you're the best, for example, and then tell everybody else how you did it, then they become better. Give the opportunity to them to become better, which forces you to become better because you don't want to lose your number one spot in the rankings.
Absolutely. And it probably helps that it's not a commercial venture, right?
Yeah.
There's no proprietary technology. We're here, and the whole purpose of everything we're doing is so that our students succeed, right? That's the whole, and so, if the Barker Redbacks, if we get to a point where we're succeeding because we've got a bunch of mentors that are really smart and are building this robot that's really good, then we failed, right? It's really about if we can teach our students so that our students have this amazing capacity to design and build mechanisms, and because of that, they end up winning competitions, then we're actually succeeding. So that's what we're constantly aiming for, is to sort of equip our students so that they are capable. And then, hopefully we also build in leadership skills and things like that, so that then they're able to actually go out and help other teams and help, younger students. So we've got a mentoring program where our students that come through the older years then go down to junior school and help the younger kids as they learn with Lego and build Lego robots. So all of that.
Culture.
Absolutely.
How large is your team?
We currently have about 36 students that are active in the team, and that's not counting our year 12 students that are sort of leaving. So there's about 5 or 6 that are sort of, we don't quite kick them out, but we sort of encourage our year 12 students to focus on their HSC. It's such a big deal here, and they really need to succeed in that. Like, that's, it's a defining moment in your life that makes it much faster to get where you want to be. So if they can succeed in the HSC, it makes it faster for them to choose whatever study they want to do, whatever else. So that's their aim. So we sort of pick them up for the first robotics competition. We pick them up sort of midway through year 9, and we do a bunch of training, and then they start competing sort of the end of year 9 through to year 11, and then the end of year 11 they move on to the HSC.
Do they volunteer, or can you suggest to somebody, hey, I think that would be a really good fit for your personality, for your objective?
Yeah, so we definitely have. So the program actually was started by a number of people in the science department. So Macquarie University first sponsored First Australia, and Mike and Luann Hamlick started that program, and they've been fantastic at sort of growing it here in Australia, and they've done a great job. And then they came and did a pitch to some of our students here, and they said, oh, that sounds really exciting. And so they went along and joined the Macquarie University team, and then 2 years later they said, can we start a team? And Sarah Cormio and Cameron Dern, 2 of our teachers here, to their credit, did an amazing amount of work to get that up off the ground. And some of our parents, John Nichols, Manuel Zamet, were some of the founding people that sort of got involved and said, we're going to back this, we're going to make it happen.
How long ago was that?
That was 4 years ago.
Yep.
Yeah.
So you've got a long way in just 4 years.
Indeed. Yeah, a massive growth curve.
How many students have gone through the teams?
Only about 25.
Right.
Yeah, we've only had about 25 students. So, we started with a team of about 5 or 6, and this year we've got about 35 students, and then next year it will be a very challenging year because we're going to grow from about 35 students to about 70 students in the FRC team. And that's because we started a sort of continuum all the way through from middle school and junior school. We've got about 45 students in year 5 and 6 doing robotics in Lego. And then up in the middle school, we've got about 60 students doing that. And so we've got, another 30 students from year 8 who'll move up and they'll become a part of the team. So it'll grow to 60. And then the year after that, it's going to grow by another 30 students. So we're going to have 100 students wanting to theoretically be involved in the team.
Do you want to spread it to the whole school? Is that an objective? Like as many kids as possible?
Absolutely, if we can.
How do we
that? Exactly? Yeah. And we don't know exactly yet. We're working on it. Basically, we need more mentors. We need people that are willing to come alongside and help and coach. And that's a very challenging role because the temptation is to want to build a robot, right? But you're not there to build the robot. You're there to help students learn how to build the robot and choose to do that well. And so you're sort of guiding them and helping them through. And it's tough because it's a very pressure-filled environment. You've got a very limited time to build a very high-performing robot. So that's challenging.
I should also ask, do you teach as well?
I do. A lot of our parents ask the same question. How do you teach? The answer is with some difficulty. The school's been fantastic. They've allocated a substantial portion of time for me to actually be leading robotics and make that happen. And that's been excellent. And that's growing over time. but there's definitely a challenge to try and balance both teaching and managing a very dynamic and growing program.
I should ask, what do you teach?
I teach programming. So that's
ICT.
Absolutely. So ICT. So I teach my main bent is programming and teaching students how to code and create something from scratch. But of course we do media, we do like digital web design, all that sort of thing as well.
And at Barker, is your ICT separate from your TAS?
It is, yeah. We're sort of unusual. A lot of schools will have an integrated TAS and an IT department. Ours are two separate departments. We're fortunate to have enough students coming through our IT program that we have a separate faculty, and we have some of the best teachers in New South Wales, I think. It's a really
Quick
fantastic
question.
group.
What is TAS?
Oh, indeed. TAS is Technological and Applied Studies. So it's all your woodwork, your sewing, your cooking, all of your arts where you're sort of fabricating things and designing, that's in TAS. The other side of it is all the design and technology component, which is now blending more towards your sort of microcontrollers and Arduinos and integrated programs. And so that's where Barker as a whole, as a strategic move, is saying, our students are going to get more out of this, like they do in robotics, if we start to integrate some of these components together.
Right.
And so, so we've just introduced a integrated STEM course, which was developed, I think, by Scott Sleep up in Newcastle. And he's done an amazing sort of job of putting that together. And so we'll be using that over the next few years to sort of integrate it into curriculum. So there'll be some robotics in there. There are going to be some other integrated programs where they design and build sort of innovative products is the idea that have a real science and technology focus.
And is Scott Sleep at the university?
He's a doctor, and I'm not sure where he's actually. I'm pretty sure he's at one of the universities. I'm not sure if it's the University of Newcastle or not.
Okay.
Yeah.
We'll have to reach out to him as well.
Yeah, he's fantastic.
We'll Google him.
Yeah,
But I wanted to ask you now, fast forward, so the students will spend 1 or 2 years in the team, and then they come out of it the other end. And,
right.
How has that experience plus all the knowledge that they have accumulated affect them going forward? So whatever they might want to do, HSC is obviously one of the things that they will do. And for the sake of people listening, HSC is the main examination in Australia for gaining entry into university. So that opens up the door to pretty much university life.
Right, exactly.
And not everybody will choose to do that.
Yep.
Regardless of whether they do the HSC and go into university. How is this experience affecting students going forwards with their lives?
Sure. There's probably sort of three main things the students get from it. The number one is they become, hopefully, masters of scheduling. And I know that sounds like small, but it impacts every area of how they choose to approach life, right? So you've got students who come in and suddenly they've got to balance, I've got a build season where I'm trying to build a robot, I'm trying to beat the best in the world, and at the same time, I'm trying to negotiate with mum and dad 6 months, 8 months in advance. Where are we going on summer holiday? How is that happening? How am I going to manage my assessment schedules?
I thought you're not going to summer holiday.
Exactly. So that's often the negotiation. Mum and dad, we can't go on holidays from this date to this date.
Like us.
That's right. Yeah.
So high stakes for a period of time. There's a lot of high stakes competing objectives that they have to balance somehow.
Absolutely.
Scheduling.
Right. So learning to prioritize. Within that, then there's a lot of flow-on effects. Like, how do I build a robot in 6 weeks and make wise decisions about what goes on and what doesn't
in a team?
And so the whole question of how do I negotiate with other people who have a conflicting understanding of what good design looks like in this case.
Conflict resolution.
So conflict resolution, negotiation, working out, and often decision making. Right. So how do I make the best technical decision? And the answer is often we don't actually know what that is. So we're going to try a number of options, and that's really healthy for them because they learn that decision making isn't fixed, right? That if I make a decision now, that doesn't mean that I'm going to have to follow through on the same decision in 5 minutes. If it turns out,
is an option.
Absolutely. Right? If that decision turns out to be the wrong one, we'll make a new decision, right? And so choosing a decision then and choosing them quickly and moving on becomes a very healthy thing for them, and so they become much more flexible in the way they approach their decision making, and that follows through the rest of their lives. Then I think the next big thing that happens is the motivation for them to achieve in their other subjects goes up. Yeah. They see purpose in what they're doing. They see that if they make choices, it's going to have a flow-on effect, and that results in success. right? So if I choose then to actually study, I'm going to get the benefit of that. And then they've got a bunch of other students who they work with all the time, who they tap their brains. And so it's often they'll come down here, and especially in build season, they'll come down here, be talking about homework. They'll go sit down, work on something, finish that, come back, and then start building the robot. So that's a major benefit as well. Mm-hmm. And then finally, I think it gives them a vision of what's possible in a broader perspective than any other student gets, because they see the best in action, right? They see that, this year's challenge was to pick up these yellow balls and shoot them into a funnel that was sort of 2.5 meters off the ground. So you had to make this big parabola to go up and then back down into the funnel. The best teams in the world were shooting them at about 15 balls per second.
Yeah, right.
So when we started, our decision was, well, what do we need to do in order to succeed in this competition? We sort of made out some stats, and the question was, is that even possible? We said, we don't know, but that's what we've got to aim for, right? And so setting high goals and following through to make them happen, they see it's possible, and so they start, without even realizing it, starting to do it in their own lives. And so that leads to students who are more successful, right? And hopefully have better character as they've come through the process of dealing with other people. So hopefully we've helped form them and shape them as leaders, and help them negotiate what it means to work with other people. And so they walk out at the end being more successful.
So with the cohorts that have left Barker now to go on to university, what have they become?
Yeah, there's actually very few, right? Because we've only been in operation for a few years. But one of our students, Alistair, I think you may hear from him later, he's actually at Macquarie University, and he's sort of got a scholarship to sort of attend there. So he's really enjoying that. I think he's conflicted at the moment between studying and the robotics, and loving both and trying to figure out how do I balance them. One of our students, Matt Buffer, I think he's at Sydney or UNSW doing engineering, and he is working with a startup on quadricopters. I think that's probably about all I can say. But he's loving that, and so going from textbook learning to really quickly engineering and building things and prototyping, and sort of that startup, I guess it really inspires for them. They really like the startup culture, really, because that's what they've been through. Yeah,
cool. It's probably a silly question, but I wanted to ask anyway. How much stress do these students need to go through in order to achieve their objectives in the team, as part of a team? And how many say, I want to give up, this is too much for me? How many stick with it and get to the end? And what is the effect of that becoming familiar with that kind of stress level going forwards?
It's a really good question. So I think there's probably two parts to it. Number one, we have students who come to the program and they see it, they're involved in it, and they go, this is too much time. And honestly, that's, for a lot of students, that's wise decision making, right? They go, I can see if I get involved in this, it's going to be a black hole in my time, and I've got other things I also want to achieve, therefore robotics for the moment isn't for me. Then the other side is you have a bunch of students who come in who love it, and then choose that even though it's hard to manage the priority and the stress, I'm going to make it work. And it's those students that get the most out of learning the prioritization and how to make things work and how to schedule things really well. The stress itself in dealing with conflict resolution, negotiation, dealing with the challenges of a very short timeline and deadlines, and the engineering challenges, it's hard. It's hard. But it's not just on one person, right?
Yeah, it's a whole team.
You're right, it's a whole team. And so when we've got 35 students building the robot, we've got a team. This year's robot had to sort of climb a rope, 55 kilogram robot climbing a rope that's about 1 meter long, and you had to do it, depending on, we calculated that you probably had to do it in under 5 seconds to be some of the best in the world. We got it down to 3. Right? And so our students designed about 15 prototypes to get there, about 10 in the first 2 weeks, and had tested them. And so that process of a small group of about 5 people going through an iterative design process very quickly takes out some of that stress.
How do they do that rapid prototyping?
Yeah, so
many companies couldn't do that.
We're really fortunate. We've got a very sort of, plentiful tool shop. So basically there's a few things we do. Number one, we use laser cutters. We have a CNC router, and we have a bunch of parts that are just sitting around ready to be used. So anything we basically not destroy, but we pull apart old robots and scavenge all the parts, and they go back into the parts supply. It's too expensive just to keep them on the robot. Yeah, so we sort of reuse them as much as we can, and so they've become familiar with all the parts from either previous years or from the off-season training we do with them, and then they start designing and building the prototypes. So we've started to encourage them to do it using CAD, which means that if we want to build a second robot, which basically we have to put a robot in the bag at the end, and then you have to work with a second robot, then that allows us to duplicate the robot fairly quickly and reliably and precisely.
So CAD is computer-aided design, software that you use to create mechanical designs, and then you pass them through a machine that creates the actual physical part.
Indeed, yeah. And so for us, the parts in the first instance are often laser cut on sort of thin plywood or thin MDF, and then or we cut them using the CNC router. And so that means that we can students can design something in the morning and have a prototype running of it in the afternoon. So, and those prototypes, let's be straightforward about this, they're rudimentary, right? They're not a finished product. It's basically, for most of them, exactly. So for the shooter this year, it was 2 pieces of wood with some holes cut out for some bearings, and then you stick, your hex shaft through there, and then you drive it with the pulleys, and you either, sometimes I'll drive it with drills, so you've got, hex sockets that are driving the shaft directly, or you're hooking up some 12-volt motors just to the battery. You're not doing any software control at that point. And so, it's rudimentary, but it tells you enough of what you need to know to say, do we think this is an idea that we can follow?
Do you have an inventory system?
No. We have talked about it actually this year. We had a real problem last year. Somehow we ran out of bearings. And that's a real issue.
When you needed them the most, right?
Yes. Yes. And when you're designing a shooter that you need to shoot things through really rapidly, and one of our approaches was to try and create 2 shooters that operate side by side. Yeah. But of course, that increases the number of bearings you need by double. And so in our shooter, we had about 100 bearings, and I think our stock of bearings was about 60. And we ordered in another 40 at the start of the build season. But when you've got 5 different teams prototyping different mechanisms, and each one is using 3 or 4 bearings, plus then you've got a shooter team using 60 or 80, it was like, we were literally stripping last year's robot and pulling it wasn't supposed to be stripped that much, but
down to bearings.
The whole drivetrain, everything was scavenged to pull bearings out. It was just, So yes, we need an inventory system. We've asked some students to work on it, and they've come up with some ideas, but it's tough. And, as much as anything, one of the difficulties for us is having a culture where students want to continue to do that, right? So operating an inventory system is hard. Getting the students to clean up all their parts and leave a clean workshop at the end of the day is hard. And part of that is building a team culture.
How do you get the students to do the non-sexy jobs?
Like sweep the floor.
Yeah.
Part of it is we do feedback at the end of every season. And so at the end of this season, one of those conversations was, how do you feel when you walk into a workshop that looks like this? What impacts does that have on the success of the team? And nearly every student was like, we don't actually like it. We want a clean workspace. We want it to work well. Now, translating that to individual action to clean up, we'll see how we're working on that one.
Work in progress.
How do you get them to do things like documentation? Because from my understanding, you get to keep the knowledge that you've generated, and you're passing it on to the next year. I can't get myself or the developers to do documentation.
The code
How do you get students to do it? Yeah, the code is the documentation. How many times have we heard that?
Just read the
code. The short answer is we don't. The longer answer is, so we've got staff who are working as robotics coaches, and then we've got other teaching staff, and we've got to, one of the keys to our success has been our off-season training program, right? Where you finish the competition season, and then you start saying, what are the weaknesses our students have that we know we're going to need to fill before next year? And so what we did to try and fix that was to develop almost like the scouts, right? Where they've got a badge system. And so we've got a badge system basically in place where, for each area, let's say it's mechanical, programming, electrical, pneumatics, there's 5 levels, let's say, and different ones, there's different levels of technical depth needed, so there's different levels available. But basically they go through and they earn those badges. And so that then gives them the right as such to work on a different component of the robot when it comes to build season, which means they've got this motivation to actually achieve because they want to do more on the robot. But the documentation of that is not complete, and we're working on it. And that's, it's going to be a benefit for us as we sort of tell the kids, this is what you need to achieve if you want to be a subgroup leader. This is what you need to achieve if you want to be the team captain. Mm-hmm. You need to demonstrate skills and capacity. And for the moment, we are communicating to them, but it's not documented anywhere. And so that helps, as we get that more formalized, it'll help our students to aim higher, I think.
So how did you set up the training program? What does that look like?
So at the moment, it looks like our coaches who are great. They basically have developed the program, and so they know at this level, this is roughly what you're going to do. But when I was referring earlier to the problem of having 30 students turning to 60 and then 100, is that we need to be able to scale that. Mm-hmm. And so being able to scale that means we need to document those levels so that other people can come in, see what's required for that level, and then we can slot the right staff and the right coaches in who have that ability at different spots, and so we can train more people more quickly.
How are you delivering the content? Is it face-to-face?
It is, yeah. It's all face-to-face. There's nothing online or anything like that yet. It's all face-to-face in workshops. And, part of our feedback we got from our students this year was we really love that it's informal. They like that they get to the end of the day, they come to robotics, and it's not another class as such.
But when Marcus says content, do you actually have, say, allocated 30 minutes to talk about how to use this microcontroller, for example, and here's the basics, and then off you go and play around with that?
Absolutely. Our programming workshops, for example, one of our students who led the programming team last year, he was the second or third in charge. He is basically developed a whole set of workshops where he's teaching Java, teaching students the basics of Java, how it all works. And that's been the last 6 or 8 weeks. And then in the next 2-3 weeks, they're actually getting hands-on with the second robot that we built this year. And they've stripped that back to a drive base, and then they'll start programming and saying, okay, if we write this code, how do we read the sensors? How do we make the motors run? How do we then start developing code that reads, the potentiometers on an Xbox controller so that you can then write some acceleration code that gives you a nice acceleration curve, and you're not, suddenly ramping up the amps on the motors too high. Yeah, right. So all sorts of things like that.
Wow, okay. I'd like to switch a little bit and ask your advice.
Sure.
Let's say that you've got a teacher who says, one day I'd like to go to the NBA finals for robotics and take the students from my school with me, but I don't know where to start.
Yeah.
How would you advise a teacher with not that many resources, we're just getting started. We don't even know what this whole thing is about, but we just know that robotics is a good idea for all the reasons that we mentioned. Right. How would you advise them to get started?
Yeah. My advice straight up would be to go with Vex Robotics.
So these are a Lego brand, is it?
No, so it's a different company. So they, basically their vision was to make robotics accessible for every single student. And so they developed kits where you can basically put the kit together. You've got all the pre-designed components for you. Yeah. So you don't need to do any custom fabrication. You don't need to have any of the expensive equipment like laser cutters and CNC routers. You just don't need it. And that's brilliant. And then you and everybody else is in the same constraint. So there's no uneven playing field for resources. It's just genuinely, I've got a kit, what can I build out of it? And
there are competitions specifically for Vex robots.
Absolutely, right? Yeah. So Vex is actually the biggest competition in the world. Yeah. So last year they won the Guinness World Book of Records record for the largest robotics competition. I'm really bad with this. I need to look it up. It's either 14,000 or like 40,000. It's obviously a big difference. No, teams. So teams, around the world. And it is the most globalized robotics competition around the world.
So there'd be one of those competitions in most major cities.
Absolutely, yeah. So Australia's kind of a little bit behind. Barker is actually just starting Vex in Sydney. So we're going to be hosting competitions here at Barker. We've just started up. We've got in our middle school, we've got a number of teams that are starting to build with the Vex robots. But the big thing for a teacher who is just getting into it is that the curriculum that Vex puts out is incredible. Right. They've got online learning resources available everywhere. So you basically go on there, they'll teach you, they go through the major engineering principles, they go through thinking through strategy of how the game will play. They go through and show you, how do I design a CAD model of my robot, right? So instead of building it from scratch, I can go in, pull all the components, put them all together, and suddenly I've got a completely, computer-aided...
On the screen before you take a screwdriver and start putting things together.
Yep. They've got a virtual environment where you can program your robot and then watch a virtual robot do those. Yeah, simulate it. So they've done a phenomenal job.
Is this Zero Robotics?
Yeah, so Zero Robotics is different. So that's I think it started in MIT, but it's basically I don't know, when you were like really young kids, did you ever have those toys where they're like the shape and they've got the two halves and you pull them apart and you put the shapes in? They're almost like an octagon, but like a decagon. I don't know, dodecahedron. What would you call it? And anyway, so it looks kind of like that. If you can imagine that.
And put some links there.
But it's kind of like a ball with a number of sort of corners cut off, if that makes any sense. And basically with Zero Robotics, if you program well enough in a virtual competition, then you can actually get your code put on one of these actual little objects that goes in zero gravity on this International Space Station and then shoots around. What? So yeah, it's amazing. So we actually had our Zero Robotics team here at Barker actually for the first time made it onto the space station this year.
Really?
So they got to see their code running in zero gravity on the space station, which is pretty amazing.
There's another interview. Going into space.
Well, we had
so VEX is a good place to begin. You get the hardware, you get the curriculum, you can train yourself even if the teacher is not familiar with all these technical topics. Right?
Exactly. So the students, even if the teacher's learning while the students are learning, totally fine because everything's laid out for you, which is fantastic.
Yeah, and which is very good for the culture as well.
Indeed, indeed.
In Australia, the culture is very level in terms of hierarchies.
Mm-hmm. It's great to have a teacher there who is an expert and knows exactly what they're doing. Sometimes it's just as valuable to have somebody there, who's still learning themselves and is figuring things out as you go, and that gives the students permission to not feel like they need to know it straight off. Like there's not that criteria of success because they're still learning as well.
So in terms of a school organizing perhaps a space like you have for your space, amazing, right? But not every school is fortunate enough to have a dedicated space. So how would they deal with that?
So Barker started out of a storage closet in the science labs. That's where
humble
we started.
Beginnings.
Yeah, humble beginnings.
Doesn't really matter.
No, it doesn't matter. All you need to do is just start. Genuinely the truth. You just need to start.
Don't come up with excuses that I don't have the right space or I don't know anything about robots, right? That's an excuse.
Nothing will ever be perfect, right? And there's people around who would love to help you. We're one of them, and there's lots of other teams as well that will help you as well. But just get started. That's really the key, is just get started. So if you want
local competition,
so you can look
if there's
up.
If there isn't one, maybe start one yourself.
Absolutely. Right? Yep. Absolutely.
Because VEX will also provide you with information on how to set up.
Indeed. So you can So we will. So if you need any help with that sort of thing, get in contact. We'll help you. I can put you in contact with VEX people. So if you're in an area, like let's say you're in Australia or another part of the world, and you realize VEX doesn't exist, let us know. We'll help you out. No problem. Because really, it's about students getting the capacity to learn and increase their skills, right? Doesn't matter who you are, doesn't matter where you are. What we're about is really about everybody in the world having access.
Do you see any difference between engagement with robotics between boys or girls? Is there one or the other? Like, do girls actually like robots?
They love it.
Now co-ed down to what year?
Yeah, so in Barker, it's a little bit of a challenge at the moment. The reason we found it a challenge is because the school is starting to go co-ed now. So we've been co-ed for, I think, probably 25, 30 years up until year 10. So girls would come in at the start of year 10, and then they would go through to year 12, graduate and move on. But the rest of the school was all just males. And so by 2020, the school will be entirely co-ed, and that's going to make it a bunch easier for us, because what we've had a number of students who'll come in, they'll be really excited about it. We'll make some announcements at the start of the year for year 10 saying, hey, if you want to join, come and join us. And the girls go, this is great. And they come down and they see the robot half built because we're already halfway through the build season, and they go, oh, there's nothing for me to do here, right? Or there's so many people that are already so skillful. And so what we're trying to do there is basically we'll introduce STEM and robotics much earlier to them. And it'll just be a normal progression all the way through the college. But, for example, when we went and helped start a team at Pymble Ladies College, there was we did a presentation to their assembly. The girls just loved it. They loved the robot. They loved everything. And I think they've got a team of 35, 40 girls, like within 6 months, 12 months. Yep. So is there a question of, are girls interested? that's not the problem,
Yes.
right? The question is really, how do we provide opportunity for them to be engaged? I think there's obviously a massive disparity in industry of girls and females in STEM, whether that's biological or whatever, I don't know. But that doesn't matter. For us, we'll give the opportunity, and if they take it, they take it.
But in your experience, it doesn't seem that there is any difference. It's really about
doesn't seem like
opportunity.
it. It seems like it's largely about opportunity.
So these robots look quite expensive. How do you pay for them?
They really are expensive. There's no doubt about it. At the top end, when we're talking about Vex, they're not nearly that expensive. When we're talking about Lego again, that's completely accessible. The FRC robots, there's no way of denying it, right? It's an expensive program.
How much is a robot?
The official valuation limit for a robot is, I think, $4,000 or $5,000 US.
Valuation limit.
Yes.
How does
So
that
you
work?
can't spend more than that to build your robot, right?
You can't spend more than that to build a robot. The entire bill of materials for the robot needs to be under that amount.
Right.
However, that doesn't include anything you custom design or make. So it includes all the off-the-shelf packages, doesn't include any of your time, doesn't include the 15 prototypes you made to get there, just the final robot. So
make that 10 or 20 times? Right?
not quite that much, but yeah,
times.
you're definitely, realistically, if you want to build just the kit and the chassis and you want to sort of put some things on, you can build a robot that will compete and be accessible in the program for under 10,000 Australian dollars, right? If you want to go further...
If you want to beat NASA, what do you have to do to beat NASA? What do you have to do to beat that top 10?
So we don't have anywhere near this budget, but it is a common thing in the USA for teams to have a recurrent budget of between $200,000 and $250,000 US.
What?
Right.
NBA,
So
man.
we're
NBA
competing.
Finals.
Yeah, it's amazing. We're competing at a fraction of that budget, but we still have. The school's been very generous in funding us. Yeah. So that's our primary sponsor is the school. Our next sponsor is the parents of our students who help pay for our students to go on these trips to actually get places and compete, right? And so those are our two big funding sources. Then we have a number of really sort of generous sponsors who are helping us out. So we have aluminium suppliers, engineering plastic suppliers. We have robotics parts suppliers.
You're allowed to mention who they are.
Oh yeah, that'd be great. So Aluminium Warehouse over at Brookvale, they've been absolutely fantastic in sponsoring us. All plastics, they've been amazing as well. We've got IFI, Innovation First International. They actually own Vex. They own Vex EDR. They own a bunch of companies. They're our major sponsor at the moment, and they sort of help us by giving us parts every year, and that makes it cheaper to build robots. But their heart to actually build STEM education is just phenomenal.
Yeah.
Like I was speaking with some of their leaders about the whole program, and they were like, Vex EDR is a charity, basically. It's basically a zero-sum game for them at the end of the development costs and everything else like that means they make no profit from it. So it's phenomenal with the amount of work that goes into it. Yeah.
I'm so impressed.
Yeah, it's really amazing. Yeah. And then we use a management platform called Bitrix 24. That's phenomenal for planning calendars, for our students to be able to communicate online, for task management, all integrated in a system. They use it on their phone to chat with each other and communicate. That's been amazing. So they've been sponsoring us for the last year. In fact, if you want to try it out, I think it's still valid. There's a coupon. If you put on the coupon Redbacks, then you'll get unlimited storage or something like that, and you'll get a discount.
So that's something for schools, right?
No, it's used mostly by industry.
Oh, industry, okay.
Yeah, it's actually the biggest thing. Sorry?
Is it project management software?
Partially project management, but I think the biggest thing it's used for is actually CRM, like customer relationship management. Yeah, the project management is growing in its capacity. It's not perfect yet, but it's very, very good. And so that's what we use. So we've got a bunch of monitors down that show up, task lists for students to do that they put together, and a calendar of what's coming up, and that's on the side of our lab wall. So, they can... There's both a virtual thing in their pocket and on the walls at all times. And then we've got ARNet, who are, Australia's Academic Research Network. They're a massive ISP, and they're phenomenal. They've been supplying mentors for us for the last 3 or 4 years, and that's made a significant difference to our technological capacity to sort of build advanced robots. Yeah. So those are our major sponsors.
Yeah.
If a company wants to sponsor, what do they need to do?
Yeah.
How do they go about it?
Absolutely. If you contact
and why
us...
would somebody sponsor you?
Yeah.
Why bother? Sounds expensive.
It does sound expensive. The biggest reasons people sponsor us is actually because they see it's a good thing. That's genuinely the reason. Is most companies say, we really appreciate what you're doing and the students and the skills you're growing, and not just that it's about Barker, but you're really trying to reach out and make this an Australia-wide thing, right? You're making this bigger than just yourselves. And that's really the aim, right? Is we may be pushing the technological boundaries, but hopefully we're leading a bunch of other people and helping and make it possible for everybody else. And so that's what people see that and they say, we want to be a part of that.
It's the right thing to do.
Yeah, absolutely. Right. And, for ARNet, one of the things they said was, we can see that the people that you're developing are going to be the people we're hiring in 5 years. And we want them to be extremely competent. We want them to be technologically savvy in a really, profound way. So one of our friends over in San Diego in robotics works for Qualcomm, and they are one of the major sponsors of the competition because he came into their workforce, started talking to them about it, and they said, how come you are so much more capable than all these other engineers we're hiring? And he said, well, this is what I've done. And they said, okay, we want to get on board. And so they're actually seeing this sort of flow-on effect for them where they're starting to get more students that are interested in working with them and are actually coming through, are more highly skilled. And so they're reaping benefits from their sponsorship at the same time. Yeah.
There's so much depth in that. Like what you're saying reminds me of a story I heard about NASA and how NASA picks its engineers, especially after the Apollo program engineers. A lot of the people that followed were inspired by traveling to the moon, and that's why they became engineers, and perhaps the best crop of engineers ever that came through NASA. And it's because of that inspiration, also because what they were doing, they were tinkerers as well.
Right.
So that makes good sense.
Right.
Awesome. For shout out to sponsors. Keep up the good work.
Absolutely. So there's probably, I'll just follow on, there's probably 3 ways we do sponsorship. Number one, if you can supply some sort of product or material that we're using. So, very basic. If you can supply people that are able to help us as mentors, then that's our biggest thing is having people that are technically skilled and able to mentor in a way that helps our students build the robot, not try to build the robot yourself, which is always challenging because it's always fun to try and build it yourself. And then, of course, if you're able to help us with finances to make some of this possible, then that's, of course, a massive benefit.
Rapid fire questions.
Great.
So, your favorite book?
Favorite book? My favorite book is actually The Color of Water. It's about a guy who grows up with a black mother and is Jewish.
So that's a fiction book, right?
No.
Or is it real life?
Ooh, good question. I believe it's autobiographical, but partially fiction. I'm not sure.
So why is a book your favorite?
Because it challenges so many stereotypes of what you think somebody should be, and why you should live your life. So going through the challenges for this person who grows up, going through the challenges of all this assumption and prejudice and problematic upbringing, and then to grow through it is, I think, really inspiring.
So it raises a question that we should really be asking ourselves as we're going through our lives.
Absolutely.
And that's a trigger for actually asking the question. So we'll check it out.
That's a good one.
I hope there's a condensed version.
It's pretty short, actually. Yeah, but very, very quick and inspiring read. At least I found it.
Awesome.
Yeah.
Okay, another deep question.
Yep.
What's your programming language of choice?
Java.
Java.
Yep.
Why Java?
Why Java?
Such a rapid why.
It's cross-platform. It works well. It's got so much support for people who are learning to program a new language. It's strongly typed, so people who are learn good practices. There's lots of good things to like.
Okay. Yep. We're not going to blame you for that. I used to teach Java too, I know.
Right.
Any good things on the JVM? Like JRuby?
Yes, JRuby's good. Yeah. Awesome. Tell us about a person, fictional, could be a real person as well, that has deeply inspired you. As a teacher, perhaps, as an engineer, up to you.
Yep. So probably a bit of a fanboy, but Elon Musk is very inspirational. A guy who's willing to take a lot of money, put it down on the table and say, let's do something that's actually going to drive not just my company forward, but it's going to drive humanity forward, in driving forward electronic vehicles, in driving forward reusable rockets, in, open sourcing all of the Hyperloop technology. He has a vision which I think more people in the world need, which is it's not just about me. It may benefit me, but this is really about benefiting more people than just my immediate circle.
Yeah, awesome. Good choice. I love him. He's amazing.
Yeah, he's.
What can you say about Elon Musk?
Yeah, he's like.
A lot.
Well, yeah. Who else do you look up to these days? Like, there's no more Steve Jobs.
Yeah, Steve Jobs is a different kind of person, though.
Totally different. He's a
totally different.
Person. Well, he wasn't the engineer. Musk is the engineer, and he worked from first principles.
Yeah. Right. You can learn a lot from both. Like what I take from Steve Jobs, totally different discussion now, but it's like the design aspect of his products, where Elon Musk
making things so user friendly. Yeah, Stephen did it.
So you can pick things from different amazing people, and you can come up with an ideal.
Roll them up.
Yeah.
Yeah. Steve Jobs is really interesting just for the word uncompromising. Because when you build a product, as you know, building robots, you make compromise. Right. And I think the only way that Apple succeeded is by being uncompromising.
At that level,
just insanely hard when you're building a product.
Right.
Awesome. How do people get in touch with you?
Absolutely. If you, on Twitter, if you follow @Barker Robotics, that's us, and we're active more when we're at competitions, but we would try and be better with that. If you email me, it's lgrant@barker, barker.nsw.edu.au, and those are probably the two best ways, and then we can go from there.
Awesome. Well, Lael, it was a pleasure.
An absolute pleasure. Thank you for having me.
Thank you.
That was the first part of this double interview. In the next part, we hear from Saskia and Alistair. Saskia is a current member of the team and one of the team captains. She's a Year 11 student. Alistair is a team alumni and now an engineering student. Listen to the second part of this interview and hear about life and learning as a competitive robotics team member from the students themselves. If you have any questions or suggestions, please send them to our email address, questions@stemiverse.com, and we'd be happy to answer them. Do you want us to interview someone in particular? Let us know. Visit us at stemiverse.com to get the show notes of every episode. And subscribe on iTunes by searching for the name of our podcast, Stemiverse. That is STEMIVERSE. Thanks for listening, and we'll see you next time.